Bismillah, this is Dr. Magda Talib Al-Hinai from the Department of Mathematics and Statistics, Sultan Qaboos University, presenting one-to-one functions. This presentation is exclusive for the Independent Learning Center. We start our presentation defining one-to-one functions. We say that a function is one-to-one if and only if every element in its range has only one pre-image. So in front of us we have two figures. Let's look at the figure on the left-hand side. We see that 1 has a pre-image A, 2 has a pre-image O, 4 has a pre-image E, 5 has a pre-image I. So this function is one-to-one. Now let's have a look at the figure to the right-hand side. Here we have 1 having a pre-image A, while 2 has two pre-images E and O. Accordingly, this function is not one-to-one. In other words, we say that a function is one-to-one if it satisfies one of the following two conditions. The first condition reads f of x1 equals f of x2 is equivalent to saying that x1 is equal to x2. In other words, equal images is equivalent to equal pre-images in case of one-to-one functions. The other case for a function to be one-to-one is if we have element x1 which is not equal to the element x2. This is equivalent to saying that f of x1 is not equal to f of x2. So these two conditions in front of us, one of them being satisfied, means that the function is one-to-one. As an illustration, show that f of x equals to 2x plus 1 is a one-to-one function. So we start with f of x1 equal to f of x2, and we try to show that x1 is equal to x2. So saying f of x1 equals to f of x2 means that 2x1 plus 1 is equal to 2x2 plus 1. We can cancel the 1 from both sides, so we arrive at 2x1 is equal to 2x2. Now, when we divide both sides by 2, we arrive at x1 equals to x2, meaning that the function is one-to-one. Another example, is the function f of x equal to x squared plus 1 a one-to-one function? We note that f of minus 2 is equal to minus 2 squared plus 1, which is 4 plus 1, which is 5. And also f of 2 is equal to 2 squared plus 1, which is 4 plus 1, which is also 5. This means that we have f of minus 2 is equal to f of 2 is equal to 5. So the images are equal. But the pre-images minus 2 and 2 are of course not equal. Therefore, the function f of x equals x squared plus 1 is not a one-to-one function. Now we present the horizontal line test. This test helps us to know if the graph of a given function represents a one-to-one function or not. So, a function y equals f of x is one-to-one if and only if no horizontal line intersects the graph of this function in more than one point. And again, here we have two illustrative figures. The figure to the left-hand side, we can see that the horizontal line in red is cutting the graph of the function f of x in 2 points. So this is not one-to-one. The figure on the right-hand side, according to the horizontal line test, represents a one-to-one function. Example, apply the horizontal line test to the graphs below to determine if the functions are one-to-one or not. We have a figure to the left representing y equals x cubed. And we can see that by drawing a horizontal line, it will only cut the graph in only one point. So this is a one-to-one function. While for the graph on the right, we see that there is a horizontal red dashed line cutting the curve in 3 points. Accordingly, the curve to the right does not represent a one-to-one function. Now we move from one-to-one functions to the inverse of a function. Suppose we have a one-to-one function and we ask you to find its inverse. You follow two steps. The first step, you switch the x and y. So here we have y equals f of x. Switching the x to be y and the y to be x gives you x is equal to f of y. The second step, solve for y. Let's explain this and make it clearer with an example. Find the inverse of y equals 6x minus 12. Step 1, switch the x and y. So we have x is equal to 6y minus 12. Step 2, solve for y. By adding 12 to both sides, we have x plus 12 is equal to 6y. Now dividing both sides by 6, we get y equals x plus 12 over 6. Therefore, the inverse function is f minus 1 of x equals x plus 12 over 6. Another example, find the inverse of y equals 2x cubed minus 5. We follow the same two steps. The first step, we switch x and y. So we have x equals 2y cubed minus 5. Step 2, solve for y. So adding 5 to both sides of the above equation, we have x plus 5 equals 2y cubed. Now, dividing both sides by 2, we have y cubed equals x plus 5 over 2. Taking the cube root of both sides gives you y equals cube root of x plus 5 over 2, which is the inverse function of the function we have in the statement of the example. Finally, we end our session with few remarks. The first remark, the graph of a function f and the graph of its inverse f minus 1 are symmetric with respect to the line y equals x. As we see in front of us, we have f of x in green and f minus 1 of x in purple. And these two graphs are the reflection of one another in the line y equals x. The second remark, the domain of the function f is the range of the inverse f minus 1. Remark number 3, the range of the function f is the domain of the inverse f minus 1. Remarks number 4 and 5, they deal with the composition of the function and its inverse. So remark number 4 says, f minus 1 circle f of x, this is equal to f minus 1 of f of x, giving us x, which belongs to the domain of f. While remark number 5 says, f circle f minus 1 of x is equal to f of f minus 1 of x, which is equal to x for all x in the domain of f minus 1.